this? Some new Jordans? Oh no, there seems to be a security device. Hello, my name is Kyle West and this is my final project. So this is a little wiring diagram. I tried to download the wiring diagram that was provided, but I purchased special parts off of Amazon, such as the passive buzzer and the SW420 vibration sensor, and those were not on the download, so I decided to just kind of take a simpler route and just write on a picture I took. So I use Arduino IDE along with the breadboard. I special ordered two red and blue 10mm LEDs. I use a SW420 vibration sensor along with a passive buzzer. I use 220 ohm resistors for both of my LEDs, along with my push button, just to kind of resist some of that current. Yeah, let's get into the code. So to start my code, I initialize all of my variables. So I have my blue and red LEDs. My blue LED is set to pin 10, my red is set to pin 11. Vibrate is my vibration sensor, which is set to pin 5. My push arm is my push button, which will arm and disarm my project. That's set to pin 8. My buzzer is obviously my passive buzzer, and that is set to pin 4. Then I also initialize my arm and trig values, which I will call later in my code. This is my first void setup. So I set my blue and my red LEDs as outputs, because obviously as a threshold is met, they will output a blinking LED, which will happen later in my code in my project. I set my vibration sensor as an input so that if a value is met, it will input data, in which will set off the rest of my project. I also set my push arm or my push button as an input, so that I can basically tell my Arduino to arm and disarm or turn on and off. And I also set my buzzer in an output because it will output a buzz if the threshold is met or the package, in this case, is stolen. Here I have my first void loop. I initialize basically what is my threshold, which is set as val, and my button. My digital read push arm, and my val equals digital read and the vibrate. So my wiring was a bit backwards on my button. That is why if button equals high, arm will equal 0. Usually if button equals low, the arm will equal 0, which means the button has not been pressed, but I seem to have wired it backwards. So my high is now my low and low is now my high. So if the arm equals 0, basically it's going to delay, and that just means my project is disarmed. It is not armed. It has not been initialized or started. And the delay 1000 is just delay a second to read into my else statement. And then obviously if arm, my else statement, if arm equals 0, it prints disarm so as I go through my serial plotter, it was a bit easier for me to kind of troubleshoot, debug, and see where my code was running. And I also do that along with arm so I was able to kind of debug and disarm a bit better. And then if arm equals 0, pretty much everything is set to low except my buzzer as well was backwards for some reason. And so I set that to high, even though that is technically off that goes along with my wiring diagram. And that is where I set my trigger value equal to 0. So basically later on, trig equals 0, nothing happens. Everything is set to low or will be off because nothing has been triggered. So if arm equals 1, then my threshold value will equal 1, which means I am armed, which means the button has been pushed. And that is also where I set my trig value equal to 1. So if trig equals 1, which means my threshold has been reached or surpassed, which means in my case the package has been stolen, the buzzer will be low, which is technically high in my case because I have it backwards. My red and blue LED pins will flash, And that is all because the vibration sensor sensed that the package has been stolen. And then this is my final else statement. So else, basically, if nothing else has happened, set everything to low, or yet again, the buzzer to high, which means everything is off. Nothing has been triggered. The vibration sensor has not sensed that the package has been stolen. And so basically I can rest assured that I will still be able to grab my package in the morning. So this is the beginning of my flow diagram. So basically my code starts, I initialize all my pins, my LEDs, my blue red LEDs, my push button, my buzzer, and my vibration sensor. So if it's in the disarm state, my button will equal high, which is obviously backwards again, which in theory is low. My arm equals 0, my trigger equals 0, so all components are off, and that checks back to the disarm state. If it's not in the disarm state, it checks if the button is pressed. If the arm button is pressed, yes, then my arm value equals 1, my value equals 1, which is my threshold. So if the threshold reached the trigger value of 1, that basically means the package was taken and the vibration sensor has been tripped. And this is the lower half of my flow diagram. So if the vibration sensor is tripped, my LEDs will be blinking, my buzzer will be on, and as you can see, the actor or the little thief will be running away scared out of his mind. If the button pressed is no, then the LEDs are blinking, buzzer's on, which that button press would be the second one, which will disarm if I obviously either catch the bad guy or secure my package safely. And if that button is pressed again by me, obviously, it will disarm and all components will go back to low. So the final cost, my SW420 vibration sensor cost about $4. The passive buzzer was about $3. My Arduino Uno kit was about $10. Obviously, that was provided by my class. Duct tape was $3, so the total was about $20. The sources, I only modeled my push button code after Professor Ackerman's example project code, and I also got permission, obviously, from Claire Knight, my TA, as well as Ackerman. And that is the only source I use for my project code. Thank you.